Welcome to the DIY Honda Garage channel. The DTC P0533 indicates a high voltage issue with the AC pressure sensor circuit in the 2012 to 2017 Honda Accord. This diagnostic trouble code is generated when the powertrain control module, PCM, detects that the output voltage from the AC pressure sensor exceeds the expected threshold of 4.76 volts for a continual duration of at least 10 seconds. The AC pressure sensor is essential for measuring the refrigerant pressure within the vehicle's air conditioning system, which helps optimize performance. It generates a low voltage signal at low pressure settings and a high voltage signal at high pressure settings. If the sensor's output voltage is too high, the PCM flags this warning to prevent potential damage to the AC system. Understanding this error code is vital for diagnosing issues that may impact the vehicle's cooling capabilities and overall comfort levels during operation. To prevent future occurrences of DTC P0533 and to ensure optimal performance of the air conditioning system, regular preventive maintenance is essential. Schedule periodic checks of the AC system, focusing on refrigerant levels and condition. Monitoring the refrigerant ensures effective heat exchange and maintains cabin comfort. Additionally, inspect the wiring conditions associated with the AC pressure sensor and the PCM regularly to prevent corrosion or wear that might lead to electrical faults. Implementing these maintenance practices can mitigate the risks of malfunction and enhance the longevity and efficiency of the vehicle's air conditioning system. In conclusion, understanding the AC system components and their interactions is vital for diagnosing DTC P0533 in the Honda Accord. This guide outlined a structured approach to identify potential issues and resolve them effectively. By following each troubleshooting step diligently, technicians can pinpoint the exact cause of the high voltage malfunction in the AC pressure sensor circuit. Moreover, implementing preventive maintenance routines can significantly reduce the likelihood of similar DTC occurrences. Keeping a close eye on the AC system not only ensures a pleasant driving experience, but also preserves the vehicle's overall functionality and value over time. The AC pressure sensor plays a crucial role in the air conditioning system of the Honda Accord. It is responsible for measuring the refrigerant pressure and sending that information to the PCM. This sensor helps ensure that the air conditioning operates efficiently by providing real-time data reflecting refrigerant levels. The sensor is typically located in the AC system, often near the accumulator or evaporator, making it accessible for diagnostic purposes. The PCM utilizes this information to gauge the system's operational status and adjust it accordingly. When the AC pressure sensor's voltage output is above the normal range for an extended period, the DTC P0533 is triggered, indicating a malfunction within the sensor or its circuit. Several factors can lead to the emergence of DTC P0533 in the Honda Accord. The first potential cause is the failure of the AC pressure sensor itself, which may malfunction due to wear and tear over time or due to environmental factors. Another possibility is an open PD sensor line, which indicates a break in the circuit that conveys power to the sensor. Similarly, an open SG line could also disrupt the signal being sent back to the PCM, presenting false readings. Additionally, there is a chance of internal circuit failure within the PCM, which can lead to erroneous diagnostics being reported. Each of these causes can inhibit the proper functioning of the air conditioning system and requires thorough investigation to resolve the issue effectively. When DTC P0533 is triggered, several symptoms can manifest that can severely impact the comfort and functionality of the vehicle's air conditioning system. One prominent sign is a malfunctioning AC system which may lead to inadequate cooling performance. Drivers may also notice an increase in humidity levels inside the vehicle, resulting from inefficient moisture removal from the cabin air. Additionally, unusual noises emanating from the AC unit could indicate mechanical stresses or failures due to high pressure in the refrigerant system. Recognizing these symptoms early can help prevent more severe issues and maintain a comfortable driving environment. The first step in diagnosing DTC P0533 involves confirming that the ignition switch is in the on position. Ensuring that the vehicle is powered up allows for accurate readings and operation of the AC system. Next, it's essential to check the AC pressure sensor itself for any visible signs of damage or loose connections. Observing the condition of the wiring connected to the sensor is also crucial, as faults in these lines can cause erroneous voltage output. Additionally, verify that no other active diagnostic trouble codes, DTCs, are present, as multiple codes can complicate diagnostics. By completing this initial check, you can gather vital data before proceeding to further troubleshooting steps. In the second troubleshooting step, focus on the PD sensor line that supplies power to the AC pressure sensor. A thorough visual inspection will help identify any apparent damage or disconnection in the wiring. Use a multimeter to check for continuity in the PD sensor line, ensuring that power is effectively reaching the sensor. Additionally, check for any shorts or open circuits along the line, as these faults can lead to incorrect voltage readings and trigger the DTC. Establishing a secure and functional power source to the sensor is critical for proper operation of the AC system. The third troubleshooting step involves inspecting the SG line, which returns the signal from the AC pressure sensor to the PCM. Identifying any faults in this line is necessary, as a poor connection can generate unreliable readings. Again, use a multimeter to check the signal return to the PCM, ensuring that the readings correspond to the expected voltage levels. It's vital to test the sensor's output voltage under varying load conditions to verify its accuracy. If the output voltage consistently exceeds 4.76 volts at high pressures, this will confirm the sensor is likely faulty. Properly diagnosing the SG line ensures a reliable communication pathway between the sensor and the PCM. Finally, the fourth step is to assess the PCM for proper functionality. While rare, an internal circuit failure within the PCM can result in miscommunication and false diagnostics. Use a diagnostic scan tool to analyze the PCM's ability to store and retrieve DTCs accurately. If the PCM fails to register the DTC, it might hint at a more profound electrical issue needing correction. Additionally, cross-reference the DTC storage with the data logs to ensure consistency in reported errors. Considering the PCM's role as the brain of the vehicle, timely diagnosis and rectification at this step are paramount to resolve the DTC P0533 effectively. After addressing the root causes and repairing any identified issues, the final repair verification step is crucial. Start by clearing the DTC using the scan tool, ensuring that it does not resurface when the vehicle is restarted. Next, conduct a thorough test of the AC system operation to confirm that the repairs have reinstated normal functionality. Monitor the system under various conditions to validate consistent performance and ensure that the refrigerant pressure readings remain within expected parameters. Lastly, check for any new DTCs that may appear post-repair, as this will indicate the success of the diagnostics and repair process. Completing this step ensures that the AC system operates reliably and maintains passenger comfort. Please like and subscribe to the channel. See you next time.